All right, next topic. Let's read up a little bit on indexes. Any last questions on views that occurred to you during the break? You'll have plenty of lab time to come up with questions if you need to. Okay. Indexes are mostly invisible. They are used to help us sort by something other than the primary key. All tables, when you create them, are automatically sorted by primary key. You may have noticed if you do a select star from a table, you don't tell it how to order the records. They are ordered in what often is called natural order, in the order they were created in the database. If it's an auto number field, by the primary key. And they're very good at that. But how often do you want the records to display in natural order, the order that I entered them? Maybe, but not often. In the Lions Camp, we take advantage of that occasionally. We get a couple little lookup tables. Here's the list of the cabins that are available at Lions Camp. We entered them in alphabetical order just so we didn't have to sort them all the time. But if you're talking 300 million customers, you're probably not going to enter them in alphabetical order. You're going to enter them in the order that they came. So sorting by primary key isn't really useful. But when we sort by other fields, it's harder to do because now SQL has to go through the logic of figuring out what does greater than mean, what does less than mean, if it's multiple fields, how do I sort all that kind of stuff out? And so again, with 300 million records, if I wanted to frequently sort them by last name or sort them by zip code, it's going to take a while. We're not used to that. We're looking at tables with records of 3, 4, dozen, even thousands of records. Isn't going to make a difference. But when you get into 300 million records and you're sorting them frequently or filtering them frequently with a where clause, only show me the ones that are on certain, that meet certain names, it's going to affect the performance of your database. I mean, it's going to affect the performance of your front end that's supporting that database. One way to improve that, if you know that I'm going to be frequently searching by last name, if you know that I'm going to be frequently sorting by last name, first name, you can create indexes. Their only purpose in life is to make your programs, yes, the database, more efficient, execution-wise. What ends up happening is in a trade-off here for execution speed, you start losing some space. Because if we're going to create an index, what MySQL does, at least in my mind, is behind the scenes, it adds another field to the table that we never see, we don't have access to. That's just the way I picture it so that I can get my head around this. It may not actually work this way. But what MySQL does is it creates another column the way I picture it, and it says, we could call it the last name index. If we were sorting by last name, this record would be record number 17, this record would be record number 1, this record would be record number 7, and it keeps these up so that whenever you say sort by last name, it goes, oh, I got an index for that. Sort by the index very quickly because they're numbers, and it keeps them straight. Every time you insert a record, it's got to figure out, okay, you belong here on this index, and it's got to change everybody else's indexes. I don't think it does that. That would be very inefficient, right? 300 million records, and I have a new record number 2, so 300 million minus 2 records have to be updated. I don't think that's the way it works. I think what probably happens behind the scenes is it creates a list of pointers, and here's who comes after me if we're sorting by last name. So if I go to my attendance page here, you guys are not sitting in alphabetical order. What's the matter with you people? Okay. But what I envision the database doing is it's got an attachment to Robert here. Okay. And imagine a string from Robert to Karen. Okay, not too bad since the girl's gone. And then from Karen to Matt, not too bad. And then from Matt to Isaac. and then from Isaac to Steve, and so on. We just give you a rope and then when somebody new comes along that belongs between Isaac and Steve, you simply take this rope, cut it, if you will, put the new person in between, we're done, right? We don't have to update everybody else. When I say cut it, there's a way to do that programmatically, but there's no string. But now you can imagine that. And so if I wanted to ask questions in alphabetical order now, as the instructor, I could say, okay, here's Robert, he's ahead of the list. Very good, that's the right answer. Who's next? I follow the rope. Who's next? I follow the rope. Who's next? I follow the rope. I follow the rope. It's much easier to sort that way. The only challenge is when I delete somebody. If Miguel gets removed from this picture, he would have been between Robert and Karen. I have to somehow take those two ropes and remove Miguel and tie Robert to Karen again. That's just a standard programming technique. And we don't have to do it. It's already done. MySQL does all this. How it works doesn't matter. If we define an index, MySQL automatically keeps that chain of people with their ropes together so that whenever we say sort by last name, it follows the chain. If we say search for somebody, we can search more efficiently by starting at the chain, or maybe I start at the end of the chain with Nathan, because the search that I'm looking for is near the end of the alphabet, and I can search very quickly by following the ropes in the reverse direction and find Lyle if I need to. So these indexes are used to quickly sort large groups because they're already sorted. They're constantly sorted. And they're also used to speed up searches like where clauses so that we can filter things quicker when we have very, very large databases. It's magic. If you understand its purpose, how it works doesn't matter. And its purpose is to sort by something other than the key, and to filter frequently by something other than the key. We can think of all kinds of stuff, right? Like dates on orders. I want to sort by order date. Well, that might come in natural order. Might be close. So maybe we don't need an index for that. But you could create an index for every field, right? But for every field that you create an index for, you got to attach another rope to Robert. And if I'm sorting by age, then maybe his goes over here. But if I'm sorting by name, it goes that way. If I'm sorting by shoe size, it goes that way. I don't know. We can have all kinds of these indexes, but every one of these that you create, whenever you insert a new record into the database, you not only insert the data, but you have to update every single index in that table. But that ought to be relatively simple because I can take the rope between these two, cut it, put somebody in between programmatically. When you delete somebody, you have to update all of the indexes. But that should still be faster and save us a ton of time when we're sorting those records. So that's their purpose. Indexes are often part of the design. We didn't do that. Because in the databases that we've created, we don't really own them. We don't have access to the owner. How am I going to know? What do you normally search by? Put in your programming logic programs, you've already created these search boxes that are based on one or two fields. You could maybe speed things up a little bit by creating an index, but you've already created a query that sorts them, so it doesn't help much. I've never used them. But you're going out into the big world where there are hundreds of thousands of records and there are indexes defined. The good news is if the index is defined, you don't even care as a programmer. As a SQL programmer, you don't care when you say select star from employees ordered by last name. If there's an index, it gets used automatically. You don't have to ask for it. As long as the database developer builds the index in, your sort by last name will be more efficient. If you've got a really inefficient sort and you use it a lot, that's when you talk to the database administrator and you ask, is there an index on this table, on this field? If there isn't, I could really use one. But they're basically invisible. And their job is to improve the efficiency of your database. To create one, there's two ways to create it. We can create it on its own. So we can create an index. And notice here we're creating an index potentially on multiple fields. That's one index that uses two fields kind of concatenated together. So if we were sorting by last name, first name, we wanted an index on last name, first name. We do the same process. We still attach a rope from Robert to Karen. But if Steve Allen was in here, I'd have to sneak him in between there, but it looks at the two of them. We can do that. Notice there's a semicolon. Done. Interesting. Can index on a field that has null values in it. Well, that narrows it down for a lot of fields, doesn't it? Especially in Boker's world, where I don't like to make anything required. It means I can't put indexes on anything unless it's required. Ouch. But again, my database is, if I hit 3,000 records, that's a lot. Lions Camp right now, been alive for 11 plus years. I think we're closing in on 4,000 records. Big deal. But it's good to know about these things. When you create the index, it shows up on the workbench. There's a whole folder for it here. You got to create it before it pops up. Where does it come up? Oh no, it's under the tables. So here's my tables. And if I pick a table, you got any indexes, it'll say no. Just the primary key one. So let's just real quick as a demo, hardly even worth it. Create, I don't even remember the syntax. Create index, yep. IDX or IND or whatever, or I or whatever prefix you want, if you want to even put a prefix on it. Index by name. On a table, and then the fields. Okay. So that's the name of my index on the table, which is TBL employees, then the fields, last name, first name, semicolon. Grinding, grinding, grinding. Why is it taking so long? It's building the indexes, figuring out how to order them, I hope. Plus it's on my flash drive. But that's a long time for us, right? Everything we've done has been bloop, here's your green circle. And yes, I'm running on a USB 2 flash drive today, so it might be a little slow. But what it's doing is going through that employees table and figuring out how, if these were ordered, which, where, who points to what, where, and starts making that chain, if you will. Let's see how long it takes if I create one in the trips table. Right? Make me an index called index by date on TBL trips. Sorted by trip date descending. Just like your order by clause. Go. Grind, grind, grind. Ooh, that was 300 records. Why was that so much faster than the other one? Maybe because there was only one field, not two. Maybe it's just a matter of luck and time of day and the phases of the moon. I don't know. But this one took 8 seconds. This one took 1. My guess is because there's 2 fields. So now what do I do with these? Nothing. We're done. Now if I say select star from TBL trips order by trip date, and I use the right duplicate key name index, but what? I must have hit, couldn't have. Select star from TBL trips order by trip date. There we go. That was much faster, wasn't it? I don't know. I guess we could take the index off and notice this took 0.000 seconds. I don't know how I can get much faster than that. So the index must have sped it up a little bit. I'm sure we would have had a 1 out here otherwise. But there's 300 trips. It's really not that big a deal. You create indexes and you forget them. And that's part of the database administrator's job, is to not forget them, because if nobody's using them, they're taking up space. The pointers are memory locations. Those strings take up space in memory. Maybe on the server, but they take up space. And worse than that, every time I insert a record, I have to update 17 indexes, 15 of which nobody's even using anymore. My insert commands take more time. That's about all there is to indexes. We could have, and again, if this is part of the design, you could have added the indexes while you were creating the tables. So here's a create table command, a whole bunch of fields like TBL trips. There we had trip date as a date, and everything else. At the end, you simply say index on field 1, field 2. The problem with that technique is they don't have a name. If you wanted to remove them, you're not quite sure how you do it, because they don't have a name. If it was me, I was a database administrator, I wouldn't put them in my create table commands. I'd define the indexes after the fact. That way I can always remove them, because we should be able to drop an index. Can we see them now? There's index by name, and if I go to trips, there's index by date. Do you need a table name? Looks like I might, huh? IDX by date, IDX by drop index. Looks good. Go. So, no, you have an error in your syntax. Thanks a lot. There's how I use them. There's how I show them. Drop index. Oh, I have to give the table name. So if I have a sort by name in the supervisors table and a sort by name, same name, I have to designate that. So I have to once again do the on TBL trips. Are you happy now? Yep. Grinding, gone. Can I still sort by trips? Let's see how long it takes this time. Go. What is it wrong there? Oh, that took a little longer, but it still shows down here that it took almost no time at all. So for most of us, for your personal databases, I wouldn't worry about it. Because there's really nothing you can test with 3,000 records to see if they're worthwhile. But in the real world, there'll be indexes out there, and if your program is running slow or you execute a query and it takes it 3 seconds to execute, maybe you can talk to the database administrator and say, hey, can I have an index on this, please? And explain to them why, and they'll either say yes or no, and maybe you'll speed your program up. This is something to try. If there's logic to when to build them, I can't tell you exactly what that is. We also saw here that we can show the indexes for a given table. Not much to them. You can create as many as you want, but it is going to slow down your inserts and deletes to have too many. But not having them in huge databases slows down your searches and your sorts, and that could be more important. And that's the trade-off that you, the database administrator, start playing with. Let's stop there. On Tuesday, we'll talk security for, I'm going to guess, about a half an hour. Then we're done. There are questions on the homework assignment regarding security, but you can't test them. Because we're using this portable version of MySQL, we can't test them. It's kind of like the intersect queries I ask you to do as extra credit. Can't test them. You can put them in, but you can't test them. So there might be a couple of questions on the homework assignment, but most of that homework assignment you can get started on. The due date for the last homework assignment, the Unit 6 homework assignment, is 13 May, excuse me. I never said 14, you didn't hear that. 13 May, 11:59:59, that's the last day of the semester. That's also when all your updates are due. If you turn this assignment in on that Wednesday, I hope you're not looking for an update. You're probably not going to get one. If you want updates, turn them in early. How early? You get them to me by Sunday. Most of you already heard this, but if you get them to me by Sunday, that's the 10th, I think, something like that. I'll try to get them graded on Sunday, get them turned around so you have an opportunity to turn an update in before Wednesday at midnight. Wednesday at midnight is the end of the semester. I do not accept anything after that. Don't tempt me. Don't, let's say, test me. If you want to come beg, you can give it a shot, but might be in a grumpy mood. Never know. Questions? All right, all for today.